Chapter 10. Chapter 10 is all about confidence intervals. And I'm going to do two of them, one on this video and one on the other one. So let's do this problem. Biologists studied the healing of skin wounds, measured the rate at which new cells closed a razor cut made in the skin of a newt. Does that sound great? They're cutting little newts and seeing how fast they heal. Here are the data from 18 newts measured in micrometers per hour. Assume a simple random sample. Construct a 95% confidence interval for the mean rate of healing for the newts. I always like to look for this sentence to see my instructions. You always need to ask yourself, am I doing a mean problem or a proportion problem? It says a confidence interval for the mean, so it's going to be the mean. So, step one, the name. This is a one sample confidence interval. I'm going to have one list of numbers. It's one group of newts in this case. So this is a one sample T for the mean. You can say confidence interval if you want. One sample T for the mean, one sample confidence interval, but we want to use the word T in there somewhere. One sample T for the mean. That's step one. And again, if it is mean, then it's going to be T. Mean T. Step one, name the test. Step two is check the conditions. We always need to check where do the numbers come from. So step two is check the conditions. The numbers came from a random sample. Okay? So I would put simple random sample, and we could put stated. We don't want to just put simple random sample and don't put anything next to it. We said stated in the problem or assumed. And then we always need to check for normality. You have two choices. One is, can I use the central limit theorem? I have 18 newts. 18 is not bigger than 30. Cannot use the central limit theorem. So I must do option 2, which is graph. I plugged all the numbers into the calculator, and now I'm going to graph it. So I will graph, and I'll go up to graph. I gotta quit that. Go up to stat plot, turn it on. I'm going to be looking for outliers, and I'm going to do a box and whisker, and I put mine into list 1, so let's go list 1. Graph, zoom 9, and I will look at it. Number 1, I'm looking to see if there are any outliers. That's the biggest thing. If it has an outlier, then I got major problems. If I have a sample size of 18 with an outlier, that causes major problems. But it doesn't, no outliers. So we want to state that, no outliers. And then I need to see, is this roughly symmetrical? I would say approximately or roughly symmetrical, or you can say no major skewness, doesn't matter. I will put roughly symmetrical. So therefore, it is approximately normal. That is our normality check. We either use the central limit theorem or we have to graph the data. That's step 2 conditions. Step 3 is all the numbers. So step 3 is all the numbers. Step 3, x bar plus or minus t star s over square root of n. Let's get a blue marker. All right. Where do I find T star? I don't know why I'm starting there. T star. That comes from the book or a chart. So I will find my chart. You'll be given a chart on the day of the test and the AP test. All right. Looking for the chart. There it is. And you can practice, you can look along in your book or in the chart, 95% confidence interval. The degrees of freedom are 17, not 18, so it should be 2.11. So check, 2.11. Might as well put degrees of freedom equals 17 right there. Let's see, n is 18, so square root of 18. S, x bar come from my calculator. So I'm going to go stat, calc, one variable stats, list one. There should be nothing in your frequency. Hit enter. X bar is 26.1. And S should be 7.7. So let's do some quick math. Number punching, 7.7 divided by the square root of 18 times 2.11 is 3.83. We call that the margin of error, 3.83. And X bar is still 26.1. So my confidence interval, okay, I'm going to round to make my life easier in the video to go faster. I'm going to say that this is going to be pretty close to 30. And on the low end, I'm going to say pretty close to 22. Again, I rounded severely, but it's going to make the video go quicker. That's step 3. Step 4 is the sentence that has a lot of stuff in it. Almost done. Step 4. We are 95% confident that the true mean rate of healing, again, this sentence at the end is really helpful. Okay, very helpful. I just looked, what did they ask? They asked for the mean rate of healing. So I'm going to say 95% confident that the true mean rate of healing of newts is between about 22 to 30, and then I gotta look for units. I think it said micrometers per hour. Micrometers per hour. And that is the 4 steps for a one sample T confidence interval.